to get these angles to be congruent, I'm going to have to prove that the smaller triangles are congruent. So, what's given is that FG is congruent to GK, is congruent to, actually let me write this below so I have a little more room. FG is congruent to GK, is congruent to JG, is congruent to GH. So I basically wrote all the ones that have one line on them, they're all congruent to each other. And I'm going to do the same thing with the ones that have two lines. So it would be LM is congruent to MK. That's these two. Is congruent to JM. Is congruent to MN. So I just took all the ones with two lines and said they're all congruent to each other. So now I can say, I'm going to write my proof out. Statement, reasons. So my first statement is going to be my given. FG is congruent to GK, is congruent to JG.
Ms. Key,
yes?
When you wrote given right there, are those the two different triangles?
Congruent to GH. What?
No, like are those?
This is all the ones with one mark. This. All the ones with one mark are written as being congruent to each other. All the ones with two marks are written as being congruent to each other. So FG, GK, JG, GH, because they all have one hash mark. And I can also write LM is congruent to MK, is congruent to JM, which is congruent to MN.
This is all still fundamental one, right?
Yep, that's all given.
Okay, just checking.
I can then say these two things are vertical angles, and so are these. So I'm going to use that to my advantage. So I'm going to say FGJ is congruent to angle HGK. So this one is congruent to this one by vertical angles congruence.
Could you move it up a little?
Yeah. And the same thing with the ones below it, this one and this one. So angle JML is congruent to angle KMN. By vertical angle congruence. Yep, it's a good thing we're doing it in class.
Yep.
Now, we have that these are congruent and these are congruent. So what can we say about the little triangles?
They're congruent.
The little triangles are congruent. Good. So you can say triangle FGJ is congruent to little triangle HGK. And what is this when we have a side and an angle and a side? What do we write?
SAS.
SAS. Good.
What I just said.
The other one, what's the other two? Triangle what?
Which one's the smaller one?
Well, it's going to be JML, right? It's congruent to what other triangle? KMN. Good. Same reason, right? SAS. Now that we have these triangles congruent, so I'm going to draw like color it in a little bit, shade it. This one and this one's congruent. Now that we can say that they're congruent, and then I'll do opposite way shading.
Are there gonna be more than 5 steps, or?
Yeah. So now that we can say they're congruent, we can say that their corresponding parts are congruent, right?
Oh yeah.
So if we say these parts are congruent and these two parts are congruent, then we can add them up and say those two big ones are congruent. So, what I'm going to say is Fj is congruent to Hk. And that is by CP CTC, or congruent parts of congruent triangles are congruent. I'm sorry, corresponding parts. We're going to do the same thing on the other triangle. So instead of Fj and Hk, what am I going to do? So I did one set of triangles. What's the other set of triangles?
KLJ.
So I'm going to use these ones. What two parts am I going to say? Same exact thing. So I did this length. So what is that length on this triangle?
JL.
JL is congruent to what?
Congruent to
KN. Good. Corresponding parts of congruent triangles are congruent. Yep. So you guys should have the pictures drawn, so I'm not going to refer back to the picture. Once I have that these are congruent, I can say that their measurements are equal. Why can you say that their measurements are equal if they're congruent? Because what tells you that if they're congruent, their measurements are the same? So definition of congruent.
Definition of congruence.
Then I can say Fj plus JL equals HK plus JL. We're adding the same thing to both sides, so if we add the same thing to both sides, what can we say? Addition. Good. Property of equality.
Equality.
Good job, guys.
Thank you.
And then the last thing I'm going to do before I prove them congruent, well, last couple steps, I'm going to say Fj plus JL equals HK, and instead of JL, I want to put KN. Does anyone remember what happens when you put one guy in for another? Substitution. Good. We're almost done. So, now, Fj plus JL equals what? Fj plus JL equals what big segment? FL. Okay? And HK plus KN equals what big segment? HN.
Wow.
This is segment addition postulate. And the very last thing we wanted to do was to prove what?
They're congruent.
They're congruent. Exactly. Those two lengths are congruent. So we say FL is congruent to HN. Why?
Tommy, you're a genius. I look up to you.
Why? How do we go from equals to congruent?
Division, multiplication.
No.
How come you couldn't?
If you go from equals to congruent, what do you do? What do you say?
Definition of equal.
Definition of close. Definition of congruent. This is it.
Oh, sweet.
I have a